Good afternoon, everyone. This is Celso Batalha, and I'm trying to understand now that we have running Vading for the entire optical range. And then what we want to do is to go to certain specific lines and try to correct those lines for veiling and then get their real flex. And then I look at H alpha and I remember how Ogden had a lot of trouble to find the continuum, and then I pull up the H alpha. It seems to have a lot of a very long um, emission wings, and I didn't know exactly where to start, where to end, and I said, okay, let me go get some easier line to treat it, and then I thought the helium line 5875 0.621 angstrom would be a good one. So now I'm targeting this line to begin with. So in the program that I'm kind of working on here is helium 1 5875 .pro is a program that what it does, it take the record, the T-Tori record one, then slices into a window that includes this line, and then normalize. Does the same with template, plot both of them together, and then go to the files where the valence have been calculated, and then extract the average in that region, and then it plots the peak corrected for veiling, and also the absorption lines correct for veiling, and compare with standards. And then the next step would be to calculate the flux of that line. So then we have a flux that is being corrected by this veiling we observe. And then we can do correlations, we can do all kind of things. So basically, so we wanna be able to have a measure of the line flux as it comes out of the star. So to do that, we have to correct for veiling. And to do that, we have to have the veiling value at that region, but also we have to be able to normalize the spectra in that region in a consistent way. So what this program does, helium 1 5875, is to pull up the spectra record number, whatever, and then and then you select 4 points, and then it does a polynomial fit on those 4 points that you understand they fit the continuum, divided by those lines that represents the polynomial that are supposed to be the continuum. And then you have the normalized spectrum. There's the same for the template, and then we can calculate the flux using this program called Line Flex Pro. Okay, so that's the strategy. So as I was organizing my thoughts, I realized something that I would like to show you, just to give an idea how, as we move on the project, how things appear, and then we kind of okay, now I have to figure this out, and I have to stop and be careful here, and don't move unless I know what's going on. So what I'm going to do, I'm going to call this program, which is helium 1 5876 record 1. So I'm going to take the first star. Something's wrong here. Wait a second. Okay. So now I'm going to select 4 points that are representative of the continuum. 1, 2, 3, and 4. Now, this is the continuum. If I like it, I will save it. But before we go on, pay attention to this left-hand side wing here. It's kind of a going down, and it's even more severe in the template as it appears now. Look at that. See that going down? This is a problem with the data reduction pipeline that people at ESO did. I mean, we are getting a spectra that has been reduced automatically, and there is some problem there. I don't know exactly what it is, but now what you're seeing here is the line corrected for veiling. So the green line, the green dots represent the template. As you can see, the template doesn't have a helium line because this helium line required a heck of excitation to be formed. So we don't have a helium line in the template. And the T-tori that has been corrected for veiling. Now, this red line over here represents the line center. The line center is good. So the peak is the line center. But one thing you can observe is not symmetric. So why is not symmetric? So take note of that, because we have to explain why there is not a symmetry in the line as we would expect. The other thing that I note is that the absorption lines, once you correct for veiling, is not well corrected. The green dots here represent templates, and as you can see, the templates are not matching correctly. Why is that? So then I got crazy and said, okay, something is not right with the veiling coding. So because these lines are not being matched properly, okay? So I can see this not being matched, this not being matched, this not being matched, this not being matched properly. The continuum is good, but not the line, okay? So to continue with the program, now I can calculate the flux. To calculate the flux, I click on the points that I think is the beginning and end of the line, and I have the flux, as you can see right here, calculated right there, okay? And then I like it, and then I save it, and then this code, which is called helium-15876, is saving that information. Saving information about the line flux, which is 4.243 something. Save information about the Julian date of that observation, and then we could initiate and go to another one, right? Take another record number 2. But I don't want to do that. I want to see why the veiling doesn't seem to be working properly. It seems these lines are not filled up completely, right? So, but before I try to do any crazy analysis, so let me bring record number 2. So this is the second template. I'm gonna go click 1, 2, probably 3 here, and 4, okay? And then the template, see how it goes down, and the lines are not well defined because of the spectra. And again, the profile, oh, I don't know what happened. I think I click, I shouldn't. Okay, let's take the continuum here. There you go. I like it. Let's go to the next one. Number 3. Oh, there's not a lot of emission here. So I take 1, 2, 3, and 4. And I take 1, 2, 3, and 4. This seems to have a better match, but this is still, see, the template is not completely filled up. The line is still asymmetric. We have a broad line that is kind of off, right? So I could try to match a broad line here, and the red wing of this peak emission seems to be asymmetric. So now I can calculate the veiling, the flux emission. There you go. And then save it. Okay. And then go to another record, number 4. And then I go 1, 2, 3, and 4. See the decay here, right? And then I go to the template, 1, 2, 3, and 4. Again, the line is asymmetric, and again, the green dots are not completely filled up in the template. So the point I want to make is, it seems that, and then I calculate the flux. So the flux is calculated, 2.75. So the point I want to bring here is that the veiling doesn't seem to be well calculated in that region, because these two lines are not filled up completely. And then I said, okay, my gosh, I thought the cross correlation method was working properly. So then I go to the veiling, which I already sent it to all of you. I compile. And I'm going to get a veiling. There's a second. Oh. I think I passed. I want to find a veiling. Oh, there you go. Okay, veiling. I'm going to start calculating the veiling in the region close to the line. This line is 580.75, so I'm going to start at 5,800. I'm going to smooth average 6 pixel, rotation is 4.5, that's the published value for the star, and it's going to be, no, not automatic. I'm going to take 10 windows at a time, and I'm going to plot. Okay, so it's not going to be automatic, and I will interact with it. Okay, so look at this. Is the veiling well with cross correlation? If there are any spikes or emission, no. Click on the top, otherwise click below the window. So that's the automatic. It's not the automatic method, but it's the one that you have to interact and see what you want to do. So we ask if there are any spikes or emission lines. No, it doesn't. So then you click on the bottom of the line to move on. Click left of the window to go to another spectral window, or click right over the window to take a break. No, I want to go forward. Okay. Okay, wait a second. I think I forgot something here. Wait a second. Okay. So when I do calculate the veiling with the automatic method, right? So I start in 5,800, and the green dots are the veiling, the template, and the red are the templates that are being veiled by a veiling factor that should be given here. The veiling factor is 0.4. So I would think it's good. I mean, if I go like this and I reduce the veiling, it's not a good match. If I go like this, right, it's too much veiling. So this is just right, looks like. And I would say, okay, this is a good match. And then I save it, right? That's what this manual mode does. And then it goes to another window. And then you have the ability of increasing veiling, diminish veiling, or say, okay, that's what I want to do, and those veilings are good. So say good, yes. So see, it seems that the chi-square method is working fine. The green is template, the red is template veiled, and the white is the titoy. So don't you think it's a good match? It seems to be a good match, except here maybe, right? But everything else is good. It's good. Somewhat good. You could try to fix this part over here, but it's not. If you fix this part, so then you are uncovering this part over here. So the chi-square is good. So now you go to 5.8, almost next to the helium line, which 5.876, I think is the next window. So you see this line over here, the match is good. It's not so good here. So what do we do? So should I try to match it like that? But if I match this line, I'm not going to match the other one. So the chi-square method, what it does, it tries to improve based on everybody else. And obviously you can see this line is being a major drive in this process. So for instance, here would be the ideal situation for these lines, right? But not for these ones over here, right? And for this big one. Oops, sorry. So I don't know. If you go to accept that one, this looks great. Now we go to the helium line. This is the helium line 5.876. And then we don't have a match on those lines that appears not to be matching. Okay. So it doesn't seem to be working fine. You have this absorption here that is, but also this part of the spectra is kind of a. I have some problem with the data reduction. So I don't know. So let's say if you don't want to do anything, click the bottom of the window to decrease, click right of the window, click top of the window to take a break. So I'm gonna take a break, okay? So meanwhile, all this data is being saved in a file. So if I restore the veil, so this is what I got. So those lines, those veilings that we saved, that seems to be good, they have an average. I mean, we could kind of take this point as an outlier, but the veiling is pretty much 0.6. 0.6 is good. I mean, based on, if I take the median, and that's what I do in the veiling determination, the median is 0.55. But see, 0.6 is good, right? 0.6 is good. If I try to match exactly There you go. Now I'm taking, see this, these are the lines that are not matching uh, left-hand side of the helium emission. Um, and what I'm doing, I'm putting a veiling that is 0.75. And the veiled template is in green, the T-tor is in white, and red is the template. So that the average that we calculated is 50.55. That's what we got. See this green line? That's why when we do the equivalent with, it comes these dots that are not completely matching the line. So somehow for the spectral lines next to the helium lines, it seems that the vein is not matching, but it seems the reason for that, I don't know. It could be that these lines are very specific and should be better worked, but the chi-square process that we use in the in the windows before and after seems to be working fine. So just all of this to say that I would be kind of a leaning towards using the veiling, the automatic uh, program computes, and say, okay, those veilings are good, at least gives an average over several windows, and we take the median of those, so it takes the outliers away, and then we seem to be fine. And then when we apply, and then we have the flux as measured. Okay. So this is what I have in mind. So I will see. I'm working a little bit more in this coding here, and what I would like to do is to change the way we do the measurement of line flux, so that we can see and have a better visualization of the line profiles and how asymmetric the hidden line is and everything else. Okay. So once I'm done, I think I'm gonna send this code to all of you, and then you guys can play with it. Which means I'm gonna take number 5. Do the continuum. There's the template. See the veiling there? Seems to be not so bad, but it still is not matching up. The line center, the line peak still is not completely symmetric. You can see that it's totally asymmetric. And then we can calculate the line flux. There you go. Okay. Then I go to number 5. So I'm gonna do all of them. In fact, we're gonna do 4 and change from 6, right? To 92, do begin, and then this is N, and 4. Oh, yeah, I don't like that. Oh, it didn't work. Yeah, looks good. Oh, so you have a big junk over there. I don't know what that is. Template. Tutorial. So technically, that junk emission has to be taken care of. What happened? I don't know what happened. I don't know what happened. Hello. Hi, how are you?